Okay, so we're asked to integrate this here, okay, and we're going to use the method of substitution, okay. It's often helpful and much easier to use a substitute to integrate something which looks kind of complicated, because if you look at this here, you've got this bracket to the power 6, okay, and then you've got to times this by x. Now, you know, initially looking at this, you might think the only way you can do this is by perhaps expanding this bracket the power 6, so you know you'd have to use a binomial expansion, okay, and then you know you'd expand that, and then you times it by x, and then you'd have to integrate quite a few terms, okay. Now it's possible to do that way, okay, but it's going to take a lot of time. I'm going to show you a much quicker way, and what's good is this quicker way I'm going to show you can apply to lots of different situations. So we can use a substitute, and what I mean by substitute is literally I'm going to replace all the x's in here by a different letter, okay. So it's just like a football match, yeah, when you know you replace, if a player is injured or player is tired, you can replace that player with a different player, and that's what I'm going to do here. I'm going to replace these x's with a different letter, in this case u. So it would make sense in this case for u to equal what's in that bracket here, okay, and that's what it says in the question, yeah. So u will equal to x plus 3. Okay, so in other words, I can replace what's in that bracket there, and I can just write it as u. Yeah. So instead of actually having two terms, I just have one term. I'll just have u to the power 6. Okay. So that's great. That's going to replace that. However, I'm going to have to replace all the x's. So I'm going to have to replace this as well. Okay. So the question is, you know, how do I go about that? How am I going to substitute that x? Because up until now I've said that, look, u is equal to x plus 3. Well, what about x then? And what you can do, okay, is you can look at this and think, well, okay, I can work out what x is, because all I've got to do is if I take that 3 over to the side, okay, I'd have u minus 3 will equal to x. Okay, so now I know what x is. I can replace x with u minus 3, because that's what x is equal to according to the definition I used here. I just had to do a simple rearrangement. And then the next question you ask is, well, okay, I'm going to replace this, I'm going to replace this. What about the dx here? Because that's an x as well, isn't it? How do I get rid of that? Well, look at this again, and appreciate you've got a function with u in terms of x, so we can differentiate this, can't we? And when we differentiate it, it'll be u with respect to x, so we'll have du by dx. Okay, because u is a function of x, so you differentiate, you get du by dx. And differentiating this here with respect to x is easy, because x just becomes 1, 3 becomes 0, so I've got that. And what I can do then, quite simply, I want to work out what dx is, because I want to substitute it. So I can take that dx up here, okay, and times it by the 1. So in other words, du is actually equal to 1 times dx, which is dx. So I can replace dx quite simply with du, because dx is equal to du based on our initial substitution here. Okay, so a bit of work to set this up, and I've taken time to explain it, but you'll realize that this is really helpful now, and it'll make things simple. So what we do then is, we then substitute, okay, so I'm going to set up now my integral. So I'm going to call it I for integral, and I'm going to draw the integral symbol, and then my x, I'm going to literally then substitute it. So x comes off the pitch, and you put on u minus 3, okay. Be helpful to put that in a bracket actually, okay, because there's two terms there. X plus 3 comes off the pitch, you're going to replace that with u, so it'll be u to the power 6. I don't need a bracket because it's just u, but I put it to the power 6. And then dx then becomes, well, du, as we've seen there. Now what's nice about this, what's straightforward about this is now I've still got a bracket, but it isn't power anymore, isn't it? The power doesn't belong to the bracket. Okay, it's just a bracket to the power 1. And what you can do, you might find this helpful, is that u to the power 6 right at the, put it at the front. And then perhaps you'll see one thing you can do now is actually expand this. Okay, so you get u to the power 6 times u, which is u to the power 7. Yeah, because that's like power 1, yeah? So when you times, you can add the powers. So we expand that there by multiplying, and then we're going to multiply that by that. So u to the power 6 times minus 3 will be minus 3u to the power 6 gu. So now we've got to integrate, and it's really easy to integrate because they're simple powers, aren't they, to the letter u. So all you've got to do is u to the power 7, well, add 1 to it, so u to the power 8. Divide by that new power. So simple integration. 3u to the power 6 becomes 3u, well, add 1 to it, so you get 7. Okay, and divide them by that new power. Integration without limits, so you need to put a plus c at the end. Now, taken a while to explain this, but obviously it's the first question you've done here, so we need to make sure we understand every little step, okay? But you'll realise there's actually not that much work there, yeah, for quite a complicated question. And, it would have been, it's much easier doing it this way than actually expanding all that out there, okay? There's not much writing, as you can see. But one thing we do need to do, okay, if there's no limit, okay, and later on we will see a question where there's limits, but if there's no limits, okay, you obviously put in that plus c at the end, but our answer will be in terms of letters, okay, will be given algebraically here, but we shouldn't leave it in terms of u, okay, because initially it was in terms of x. So what we need to do then is replace, go back to what u was. Remember, u is equal to x plus 3, so put that back in to this answer to leave your answer in terms of x. Okay, so I'm just substituting it back in, and there you go, there's my answer to that integral there.